Hello, everybody. So, we are back for another round of me playing games while people talk around me. I have played a little through the beginning section of Bioshock Infinite, and now I went through like all the boring walk around Columbia type stuff. And now we're about at the area where things start, getting real. Stop taking names or whatever the thing is. And, so I'm here with Harvey Z.
Yo.
And Slim.
No.
And Jesse.
Ahoy, ahoy.
And that's it. Unless someone else sneaks up on me.
Wait,
oh, shit.
Whoa. Okay.
I did not mean to do that.
Are you in combat now?
I didn't mean to be in combat.
Out of salt. Fine more.
But yeah, I kind of need to be salty.
You just use up your salts?
Yeah, I used up all my salt. I don't really like that I did that on accident.
So, did you just you're saying you wandered around? Like, the first part of this game is nothing but just...
Yeah, you don't for the first beginning part of the game, you don't really do much.
Uh-huh.
Like, it's just you...
It intentionally wants you to just explore.
Yeah. It just kind of gives you the atmosphere of what's going on.
Got it.
Like, where you are. And that sort of thing. And
For the uninitiated, is this where Bioshock 2 leaves off, or is this a new story, or...
Okay, so Bioshock and Bioshock 2 both take place in Rapture.
Spoiler.
What? No.
That's not how it works.
Okay. For me, I've never followed the Bioshock series, so... I'm just curious. It's what do I need to know?
Basically, this is its own story.
Okay, cool.
This takes place in Columbia, which is it's a floated, as you can see, floating city in the clouds. 1910, I believe, somewhere 1918.
Okay.
It's that sort of. Can I go back this way? Yeah. This is where I can refill my salt.
Would this be considered a steampunk game?
Oh, it's a
Or
little.
of that genre?
It's a little steampunky, but there's a lot of.
Ooh.
It's a very kind of satire-ish. It's also very topical since it's very America is great, purge the non-white people kind of.
Ah. I love games that are purged the non-white people.
More importantly, do they worship some kind of bird Jesus?
Bird Jesus, yeah. There's Songbird is.
And there's a shepherd.
Well, so the thing you find out, as you walk by this, you look at his hand. Your main character has AD on the back of his hand.
Oh.
So there's a.
But does nobody else notice that?
Not yet.
So these guys are early adopters of
Oh, you're salty?
the CE, BCE
Yeah.
Wait, that's a person.
nomenclature.
Yeah, I messed up.
Did you throw that person?
Something about it.
I'm sorry, what?
Nothing, I was making a dumb joke. We threw a green person on the ground, is that what happened?
Yes.
That's what I was wondering. Did that
The vigor I used, accidentally used, was possession.
Oh.
1912. There you go. That's the
It said so?
Yeah.
Good sir.
Oh, here you go.
Sorry.
That's the official beginning of the rebel.
Silly? There's never a charge for the raffle. You've been sleeping under a rock?
77.
Oh.
77.
See, there's AD
That's a
on the
lucky
back of his
number.
hand.
I'll be rooting for you.
Bring me the bowl! Is that not the prettiest
So is this...
girl?
These are supposed to be Americans or American values or something?
Yeah, a little bit. I mean, it's nationalism and kind of when you come into the.
Number 77, come and claim
I
your
mean,
prize! First round!
I get to throw my prize is I get to throw the baseball at the. See this when I say. Yeah, this. It's not like.
I don't like this anymore, guys.
What are you doing? Come on! Are you gonna throw it? Or are you taking your coffee black these days?
Okay.
It's very much like.
Look Looks like we've got a shy one here. We've got to do something about
There's
this.
only one answer to this.
Wait. It's him.
Now, where'd you get that brand, boy? Don't you know that makes you the backstabbing snake in the grass false shepherd? And we ain't letting no false shepherd into our flock.
They recognize.
Is there only one false shepherd, or is more than one? It's like the
Oh, that guy.
Things are kicking off.
Stop him! Stop him!
Okay.
Shepherd's got the lead on. We're astray.
I didn't think this was this violent of a game.
Oh, it's a very violent game.
There's like a big brother and like a little girl.
that's the others.
I know, but I'm thinking like the series.
What kind of America did you not understand?
America's not violent.
But like when you first come into the game, like when you enter the city, there's like giant statues of like big muscled George Washington and Thomas Jefferson. Like
So it's explicitly American, not just quote American values.
yeah, no,
It is actual American.
yeah.
Is it politically part of America? Like,
I can't remember exactly. It's been a while since I've played this.
Are you stealing their salt?
Yeah, I'm just getting salty.
and what's do we know anything about your character or their motivation?
Find the girl.
Like, where did they
bring
come
us the girl
from?
and wipe away the debt.
Okay.
My name is Booker DeWitt, and I was given a gun that I dropped on my way up here because, you know, you always drop the gun.
So some unknown person gave you a gun.
Yeah, and said, bring us the girl, wipe away the debt. So I am...
Do we know what the debt might be?
No. Not at this point. I mean, I do because I played the game
Right.
before.
I mean, would you expect that the character does, or are we like, is there like an amnesia situation?
It's a...
Seems
I mean,
very much thrust into the middle.
he's like a private detective-ish type person,
Okay.
and it just seems like he owed people money or something, and say, you bring us the girl, and you're good.
These are people from Colombia who told you to do this?
No. These
What
are
did they
people...
tell you to do while you were in Colombia?
No,
Or they
no.
send you?
They send us to Colombia. We're looking to...
So you're from elsewhere.
yes.
I told
Oh,
you, Comstock.
didn't realize that was right.
You sell 'em paradise and the customers
You're from, like... So you're from... You start out on regular Earth, kind of... You know, and then you get into like a... As believers as humans who suicide when the effect was... Of course.
And there's witchcraft in this game.
So Vigors in Bioshock, there was plasmids, which you like let you like shoot fire and electricity and things like that, and they're just called Vigors in it. So you have a gun in one hand and you have like special abilities in the other. To turn female. Possession trap. Oh, so I was just holding it, which is why there was a green person on the ground. I created a trap, so if someone walks into it, they become possessed. While I can just, if I just press it, I throw it and I take control of people. See, like I just took control of that turret, so now it's on my side, and it's killing people for me.
And they'll automatically attack people.
You can possess non-humans?
Yeah, well, the point of it at the beginning is, like, you possess non-humans.
Oh, it doesn't last forever?
Yeah, it doesn't last forever. Like, so the special thing that I got is that now I can use it on humans. That actually makes it better.
It's supposedly... Ah, okay.
Oh, shit. Fuck you. Who's shooting at me? So it used to like... Oh, fuck it. You know what? Go attack people.
Oh, they just blindly go.
Another turret.
Yeah, I saw that. Problem is that turret is going to shoot at me. It sees me.
And you have to spend some kind of resource to do the possession?
Yeah, so in the lower left is salt, which is basically like my magic ability. Can I make it? Yes. Okay, this is... Oh. Fuck. Life is saved, you're partially healed, but so are your enemies. You also lose some money.
Is your life being saved?
What just happened?
You know what? I'm going to possess you because you're really good. Thank you.
So, give me enough money for one resurrection?
Yeah, so I'm playing the game on 1999 mode. It's just like the very hard mode. Like, you're not supposed to. There's a secret way to unlock it that I don't remember. But like, you're not supposed to be able to play in 1999 mode until you beat the game once on like a regular mode, because this is like everything costs more, and you know everything is more difficult. And people do more damage and things like that. So like the very beginning, this part of the game is really the hardest part because you don't have any abilities and useful stuff. But once you get like multiple weapons and like special abilities and things like that, it becomes a lot easier. Like it's still like a challenge, but it never felt like ugh. This is the part that.
So the fruit bad?
What?
Are you like eating rotten fruit?
No, I was eating regular apples. I thought.
You just went, oh, I thought maybe something bad.
Well, maybe I didn't notice. And there are rotten apples that I can eat, but I thought it was a regular apple, and I just didn't pay attention correctly. I think this is what I need to make it too.
It's getting hot.
So that it saves it. Oh.
Does it look like a safety?
Can I possess him? I can, but there isn't anyone else for him to fight.
There's not very good.
Yes, nope. Please don't do that.
They're allies. Oh, the name.
Got him. Yeah. Yeah, this is basically one of the hardest parts of the game is just getting from when you're on 1999 mode, is getting from here to the vigor guy and getting the second vigor. Because I don't think there's like a autosave between everything kicking off and getting the Devil's Kiss. So you need to do it all without dying and like losing all your money.
The first vigor was the possessed people, second vigor is fire.
Yeah.
That wasn't no sample.
Navigation.
Oh, wow.
Oh. There you go.
So you're gonna drink in a bottle?
I told you,
Yeah.
stock. You sell them paradise, and the customers
I don't know.
for every chore.
It's a thing that happens.
Also salt.
Sure, I just wonder, does everyone who has a vigor
Yeah.
also turn into a bottle when you kill them or drop them?
No, I mean he had like the idea is you drink the thing and
Is it
it
temporary maybe?
and
So
it
it's
like
extra?
it temporarily gives you the power
Okay.
or whatever. But for some reason Booker just drinks it once and then
Forever.
I have
to be
it.
fair, you are the false shepherd.
Another thing.
Ow.
Surely you could just get a pair of gloves. There's one glove. Looks like kind of a weirdo, but still not.
Well, he didn't know he was a false shepherd until he got here.
So he just had a weird birthmark of AD on his hand.
You had no idea that it would be
Lived his
this
life
thing.
peacefully.
Yeah.
And did you say that that he's the only one, or that's like a thing, or do we not know yet?
It's. I think it's supposed to be the only one. Like the idea is, like the false shepherd is here to steal the leader's daughter away, which is what you're here to do. Yeah, I mean I. Oh God, it changed. Go back. Thank you. Thank you. Oh. You see, so like you can find like the bottles around. Oh. Please, help.
You gonna kill it?
Yeah, because I don't. Yeah, it's gonna start turning on me. There. Did these blow up? Oh, they do blow up. That's right.
Some fireworks?
Yep. Yay! Oh, I can set these on. Like, and there's like oil and stuff, and you can set things on fire. Anywho, so yeah, so now it's just going to be me fighting people trying to kill me. So feel free to talk about the game or other stuff, or I know.
Life in general.
Yeah, life in general. I know Harvey had a special topic on his mind.
Well, things that interest me.
Very special episode.
Very special. Harvey Z learns a little bit about himself. And maybe you learn a little bit about yourselves. Because I have some questions about space.
Okay.
Apparently this week, well, around this time of whenever we're recording this, we've discovered new planets.
Yeah.
7 of them.
7 in one solar system.
Not in our solar system.
That's correct.
That would be something.
And I heard it was like 40 light years away.
That's correct. 40 light years, exactly.
See, I did some reading on this. I read a couple of headlines. So there are 40 light years away. There are 7 planets that are habitable.
No. So, a couple things. When we find exoplanets, which are planets outside the solar system, it's easier to find big planets because they can perturb the orbit of the star by more if they're bigger, or they block more of the star's light when they get in front of them. So most of the planets we've found are large gas giants like Jupiter or something. Totally not habitable, but we're finding them. It's a lot harder for us to find smaller rocky planets like the Earth because they're smaller, so they don't move or affect the star as much. Also, because they generally might be a little bit closer to the star, just like our rocky planets are a little bit closer than the gas giants, so they might be harder to see because that particular star's glares in the light. Just harder to find.
Okay.
So the big thing was we discovered 7 planets, all in the same solar system. All of them are rocky. All of them are about the size of the Earth, so they're Earth-sized.
Okay.
Pretty similar. Nothing like no huge weird rocky ones or tiny rocky ones.
We know they're rocky though?
Yes. We can.
Did we look at them, or did we do like math and like figure out like, oh, there's a planet probably here?
The way that we discovered them was by having very sensitive telescopes look at the star and literally seeing the dip in the star's brightness as the planets got in front of them. We just luckily happened to be looking at this solar system exactly edge on. It's just fortunate. Because of that, though, we can see that. And they all go around in periods. In fact, because the one farthest away has the longest orbital period, in the observational time, which was X number of whatever, I don't know exactly weeks, whatever, we only saw the 7th planet go in front of it once.
Okay. So we don't quite know how long it takes to go around the star?
Oh, we know. We've discovered them. We've discovered them. They're not probablys. We have discovered them.
So you're saying we know how long a year is for them?
Yes. Yes.
Is it like our years? Is it?
It's in time, just like our years.
Yeah, it's in time. Do you happen to know? Like,
No.
Okay. Just curious. Like, do we know if there's water on these planets?
No. So, we know the mass of the planets, the size of them. Okay, we know how far away from the star they are, where they are.
Okay.
So we know we have a really good guess on the temperature of them because we know we can calculate exactly how much light they're getting from their sun.
And so, so this particular star, TRAPPIST-1, is a very, very cool, dim red dwarf. Okay, so all of these, so just it's only about 8 or 10% of the size of our sun.
So it's smaller.
It's
Smaller, 8 to 10%. Yeah, okay. I'm just keeping track of facts here.
and it's very cool, not very bright, not very warm. Okay,
So it doesn't sound optimistic to me.
What does that have to do with anything? It's just describing the star.
Like, could we go there someday and like colonize these planets?
It's 40 light years away. It would take
So
us
that was gonna be my
between
next question.
700,000 and 1 million years to get there with our current technology.
I was like,
I mean, that we don't have.
so we don't have light year technology stuff yet.
We never will.
Never?
I mean, relativistically, yes. That means it'll take us hundreds of years to get somewhere, and thousands or tens of thousands of years will pass on the Earth.
Because if we got something that could go 1 light year per year,
No, you can't do that. That's light.
warp drives, space,
Right, not possible. Exactly.
not possible.
Right.
Because I was like, oh, it's 40 light years away. All we got to do is find something that goes 1 light year a year. We
There
send
is something.
babies in space, and by the time they're there, they'll be 40-year-old adults who we train to colonize planets.
Sure. Except,
It doesn't seem like you're asking serious questions anymore.
That's what I was wondering, though. Light years is what I didn't know how long light years would take
Okay,
us.
so a light year is the amount of distance that a light travels in a year.
And we cannot reach that speed. yet.
Nothing
only
can reach
light
that speed.
can.
Only light can reach that speed. I'm trying to think of then, how do we get to these planets?
You can't.
So these planets will never feasibly
Well-
be colonized by humans.
You have to take slow boats. So if we sent something at the fastest thing we can go right now, it would
Yeah.
take about 1 million years to get there.
Okay.
Okay, the goal would be to somehow develop some kind of crazy good technology that can go some small percentage of the speed of light, and it would experience huge relativistic effects. So if like we accelerated something up to like 0.4 times the speed of light,
Okay.
okay, somehow, amazing.
It's not even 1. Okay, 0.4.
You
Okay.
can't go 1. That's light.
Yeah, yeah.
Okay, so something like not like a significant percentage, but not very fast compared to light.
Okay.
The relativistic effect of that would mean that like for every year you traveled in space, dozens or tens or hundreds of years pass on Earth.
Yeah.
Okay, so the only chance of getting here would be to accelerate to potential relativistic. It would take hundreds and hundreds of years to get there instead of 1 million, and thousands, if not more, years would have passed on Earth. That's what relativistic travel is. Because
Then
the closer you get to the speed of light,
Mhm.
the larger the time dilation is between how you experience time and how those who haven't been accelerated up
more
to-
time would pass for somebody who's outside of wherever you're relatively.
who has not been
Yeah.
accelerated to the speed that you have been. Exactly.
Okay. Because I got a lot more excitable about this, like just reading headlines.
Yeah, I thought you had questions about the planets. I can answer all those questions, not about fake space travel.
Well, see,
Technology.
so like, what's the big deal then? We've discovered these planets.
We want to learn about the universe. We are scientists. We want to discover, is there the chance of life on other planets? How do life-forming planets form? How different or similar are our planets from most planets in the galaxy? Those things.
And these
Science
things,
questions.
this is outside of our solar system, but in our galaxy.
Yes, that is correct.
Okay. So, but if there was life on those planets, could we even study or look at it? from
Absolutely. We
over
can see
here?
everything that comes from them 40 years. So the light that's coming to us now left 40 years ago. If they were the same kind, if they were a civilization at the exact same technologically point as we are, we would see their TV shows from the
40
70s.
years ago. Yeah.
Yeah. It's literally what we could see. Yes,
Huh.
absolutely. You can
But
see
they
anything
couldn't
you want.
probably visit us if they had like our culture or stuff, because again, they would have the
Right.
same
There's no
problems.
visiting. We're just learning.
Yeah.
The only, as you astutely point out, what is going to travel that fast is light. So we can see, listen. I mean, with EM,
Okay.
listen from
I was gonna
radio
say,
waves.
would radio waves or
That's light.
would that? Okay, that's light. So, could we send a message?
Absolutely.
Have we sent messages? We have sent messages into space.
We
but
have sent messages into space.
Could we now say we're going to send it towards these planets?
We could, but first we're going to observe them, determine if we see any signs of life. So now that we've discovered the planets, know their size, their temperature, their orbits, all these things, all the the existence properties of them. The next stage is to do spectral analysis as the planets pass in front of the star, whose we know the emission, the output of their star, like how what the wavelengths are of all the light that's coming out from that star is. We know about the star. I mean, all stars put out the same. It's just a regular light. It's not a bell curve, but there's a curve.
Okay.
It's a black box, black body radiation. Anyway, so we know what light is going to come out from the star. Okay. Then the planet goes in front of it. Okay. And so when we look at the light that is coming through the atmosphere of the planet, if we notice that, for instance, the band of light that is absorbed by water molecules is not there in the spectrum of the star anymore, that is evidence that there are water molecules in that planet's atmosphere that absorbed that exact wavelength of light.
Okay.
So we're going to do that, see what sort of composition the atmosphere of the planets have, which is going to give us some data. If there's a lot of organic molecules, complex hydrocarbons, methane, carbon dioxide, oxygen, nitrogen, all the stuff that you might
So
expect.
we can figure out like what's on the planet molecule-wise.
Only in the atmosphere.
In the atmosphere.
We are seeing what is in the atmosphere based on the absorption lines in the spectrum from the light that is going through the atmosphere coming from the star.
And if they were doing it to us, they would see us 40 years back?
Yeah.
Well, they would just see light that they can tell passes through a certain kind of atmosphere. They wouldn't see us.
But
They had our level of technology, right?
Well, I mean, I don't know what sort of resolution you can get from our TV shows, right? But you would also get
So you-
any EM messages that we are putting out. We bathe pretty strongly in radio waves because we're just sending radios all over the place. I'm not saying that it's any chance that it's strong enough to get there, but if it were, they'd see it. I mean, they also are receiving all of the electromagnetic radiation that the Earth is putting out. It's just nothing compared to what the Sun is putting out. It's probably unnoticeable in the glare of the star.
Okay.
We are not looking for the radio broadcasts. We're looking to see
What's
more
on their
information
planet.
about the planet.
Okay.
If it passes through and we see it's just 100% nitrogen, probably good bet no life there. Because we would expect to, life as we know it, I should
Yeah.
say. We would expect, if we're looking for life as we know it, to find evidence of cellular respiration. Any sort of byproducts of, cellular respiration really is what we're looking for.
Okay. If we find that, then what happens?
Then we say, it's more likely now that there would be life here. And we'll probably,
visit
probably
it.
right.
How
Visiting
can
is
we
not
interact and use that information?
What other tools of observation do we have?
Yeah.
You mean aside from like this absorption band spectroscopy?
Right. Like once we figured that part out, yeah.
I'm not 100%
Like,
sure.
is it feasible to talk about like building better, bigger telescopes and pointing them in that direction, or is there any realistic hope
So-
of ever getting like a view of more than just the star?
Yes. So in fact, NASA is launching in 2018 the James Webb Space Telescope, which is going to be the next big Hubble science amount
there it is.
of data kind of telescope. It's one of those huge multi years, tens of billions of dollars probably, giant observatories. I think. We know they call them great observatories. Just like Hubble, we sent it up. I mean, it still has been used. It is currently doing like active science, getting great data just because it was so good and big and expensive. I mean, 25 years after we built it, right? It didn't have to last that long, okay? The James Webb Space Telescope is going to be another one of those. Hubble, I think, is in the optical range. James Webb, I forget, maybe infrared. But the point is, it's going to be one of those big, years and years and years of great data, So this is a great time to discover these planets because in less than 2 years we're going to have this great observatory up there that we're being able to use. And so I forget exactly which spectra the James Webb looks in. But if it's infrared, then we'll get a better idea on the temperatures of planets. Right, we'll be able to see whether, they're more warm than we think. Could be the product of industrial, right? Are they super, super cold? Right, are we noticing any temperature variations? Stuff like that. So yes, we will be able to get more observational data. At the moment, what the next plan is to specifically look at the composition of the atmospheres to gain information about what kind of surface conditions we think are possible. I mean, literally, if we see them all to be completely sterile atmospheres, that's just good data, right? There could be some kind of weird kind of life that doesn't have any sort of respiration that we know about, but we can't know anything about that, so we're looking for things we recognize. This is one way to notice something that we recognize.
Okay.
Because this particular solar system is around a very small red dwarf, and these might be related, but not, doesn't matter whether scientifically related. Also, the 7 planets are very, 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 very close to the star, especially compared to our solar system. So in fact, all 7 planets are smaller than the orbit of Mercury. All 7 of them could fit within the Earth of Mercury, size-wise. But because the sun is, because their star is like 10% the size, and because like nuclear fusion depends on like the cube or whatever, or the, actually I think the amount of energy is the vortic? I think it's either T cubed. Anyway, point is like they're super close, but the star is super cold and super small. All 7 of them, even though they're all small, closer than Mercury, could have water on the surface.
Okay.
Okay, based on their temperature. And in fact, 3 of those 7 are in what we call the habitable zone, which means that they have Earth-like temperatures and could even have liquid water always staying in liquid form on their surface, like we have oceans. Right? Mars is not really uncolonizable by us, but it's not going to have oceans. It's a little bit too cold. Right? Venus is clearly too warm. Okay? But 3 of them are Earth enough to literally be in the habitable zone, what we call, where liquid water can be lived. Okay? Because they're compact, like close together, 3 of them fit into what is only the range of one planet. Everything's all closer together. However, because they are so close, which is great for the amount of energy, because it means they're getting the right amount of heat because it's a cool star. We think that probably all 7 of them are tidally locked to their star, which means they do not rotate. There is no day and night. One side is always facing their sun, and one side is always not. Kind of like the moon is tidally locked to the Earth. So one side of the moon always faces the Earth. That's why it always looks the same in terms of like the man and the moon. So we think probably all 7 planets are like that. So the weather might be really weird. There might be huge, constant, hundreds, if not 1,000 miles an hour winds, because one side of the planet's always being heated, and one side is always not, and it's always having a lot of hot. Like, we don't know, right? Yeah. We don't have any tidally locked planets with atmospheres in our solar system that we can study. I think Mercury is a 2 to 3 tidally locked situation with the sun. So I forget how that exactly works, but it's like, it rotates such that for every revolution, every like 2 revolutions around the sun, it only rotates 3 times. Something weird. It's has a tidally locked motion, but it's not 100% tidally locked. But all 7 of these planets are closer than Mercury, so we think they're tidally locked, which is just different. It means completely different conditions than what we're used to. So we don't know what the weather would be like, but we're just trying to find out the composition of the atmospheres at the moment.
Do we know with exoplanets like this for sure that they have an atmosphere to speak of?
I guess no, right? I mean, I guess when we check, do the point the telescopes that can tell these things, we could get data of there's no atmosphere on this planet. Right. I think that's possible. But
do we have reason to expect that there would be?
Yes. Yes, it sounds like it because everybody's like, great, we're going to do this now. We'll get some data. Especially, I think, maybe around the habitable ones. In the habitable zone, I should say. I mean, even some moons of Saturn have atmospheres. I think atmospheres are not very uncommon. I mean, it might be like pure 100% methane. You'd be like, okay, well, that's,
Sure.
But at least there's some gas around them. So I think we fully expect there to be atmospheres, at least around the ones we're interested in. That's my understanding.
So have there been interesting results from these types of investigations about the other exoplanets we've discovered?
I don't know. I'm gonna be honest. I don't think we found very many that are in the habitable zone. Mainly because it's tougher to find ones that are closer and tougher to find ones that are smaller. And so I think we're just often finding ones that are clearly horrible candidates. You know,
Okay.
we're good at finding huge Jovian-sized ones because you can. The easiest way to detect planets is to notice the star moving in its shared orbit around the center of gravity of the solar system. And when you have a bunch of or large planets, that motion
They
is
move it
a
forward.
lot. So it's really easy just to notice the wiggle of the star. Be like, okay, we can tell that there's enough planets around that star to be 25 Jupiters, right? I mean, clearly no Earths to speak of necessary. Maybe there's also Earths, but we don't know. The transit method, which is how we detect these, where we're actually noticing the dip in light as a tiny planet crosses in front of the star, is A, both harder, and B, only works if you're in the exact plane of the solar system. Only works if you can look
Oh, exactly across.
exactly such that the planets are crossing between us and their solar system. So you get many fewer candidates that you can see just because it's less likely that you will get it to have that data. So we're just finding fewer planets that way. That way is much easier to find Earth-like planets. But we just don't do it as often because it's harder and less chance of it just working out that way physically.
Is there a decent chance that there would be any other planets orbiting this particular star, or would we expect to have seen that in the map?
So
we expect them to all be orbiting the same plane?
we definitely would expect them to orbit the same plane, for sure, because the way that planets form through an accretion disk basically necessitates that they all gonna flatten out and be in a
Okay,
plane
so
in
you
that
can never
particular
have
solar
one
system.
that- yeah.
You wouldn't unless it wouldn't happen that way if it formed in the solar system. It would have to be a rogue planet that came in from interstellar space and got captured. Like, there's evidence that Pluto did not form where it is, which is why its
Has a weird-
orbit is very different, ecliptic-wise, than the other 8.
Okay.
Yeah, I don't know if I'm not saying I think it was like interstellar, but maybe it was captured from like the Kuiper Belt or something like that, or you know, a comet that moved by Neptune and got like hooked, something like that. We think it's less likely. We don't think it formed there, because if it formed there, it wouldn't be in the exact orbit of it. So all planets that formed in the solar system should be in the same plane. You had another question that you asked. I had an answer to it.
Are we reasonably sure that this would be all of the
Oh,
ones?
all 7. So, I don't have any data on that. I've certainly not heard anyone talking about, you know, and maybe there are more. We're not sure yet. However, I could certainly concede that there might be more, given during the observations that let us see all 7 were such that we, you know, like the closest ones orbited fastest. We saw many transits in front of the star, right, periodical, and then the other ones, you know, were a little bit fewer. We saw only one transit of the farthest away, the 7th planet. Okay, just the amount of time that we spent looking, like we only saw one of them, but it was enough, right? It was like we know what these 6 are, and then here's one blip. That is the right place and time for a planet with these characteristics.
And we know that blip is different from the other blips.
Yeah, because we know where the blips are.
Who's that?
We have all the orbital periods
Oh,
of the 6. And
shitters.
here's another one, right? It's like, and there's this blip is not any of the 6. You know, that must be, that data is sorry, I'm watching T-Man kill things. You know, that data supports a 7th planet, you know, that we've only seen this once. But given that we've seen this once, and we know where the other planets are, and we know where this other planet isn't, you know.
Please die. Please die. No. Thank you.
You're fighting fire guys a lot.
Oh, they happen. They're basically the Devil's Kiss Vigor guys. Like, there's a couple different, like, there's gonna be Crow guys, and, like, there are people that use the Vigors against you.
So are these like people who in the game worship the bird god, and so you're like the ultimate evil, and they're, you know, they...
In simplistic terms, yes.
Yeah, I'm totally fine with this.
It seems like those one movies were trying to explain that this was like America's floating city, but it was being crazy, and America was like, well, it's a little crazy even for us.
Yeah.
And so they've now seceded and started doing their own thing.
Yep. That's basically it.
Don't damage your allies.
Yeah, how much damage do those things take?
A lot.
This is what happens in
They turn on me like they were going to in the beginning.
Well, just because it happens if you don't do it doesn't mean it isn't the thing that happens if you do it.
What's that yellow cracks that happen?
It's my shield,
Gotcha.
like recharging.
Yeah.
It's the right-
So that's why we're excited about these planets.
Okay.
They're good candidates for Search for Life. They're multiple ones, all in the same place, easily. I was gonna say accessible, but I mean observationally accessible.
So it's more data to be collected.
It's all data. Everything that we do is data to be collected.
See, I was hoping like sometime in our lifetime we might be able to interact.
I mean, I don't even think in 1,000 lifetimes. I mean, this is astrophysics. These are 40 light years away.
That's why I was like, 40 seems not that bad, but the light year part.
Yeah. So I
That's
guess
a number I
guess
could
Units
conceive of
are
40.
important.
Yeah.
I guess I won't tell you how far away the farthest things in the observable universe are.
Just leave that teasing.
Just
Down like, huh.
Just tell me.
26 billion light years away.
Okay, so
See, I
so
can't
40
conceive-
light years is really close.
Yeah, I was like, this
In
is
comparison.
So my plans for
I
shooting.
was afraid you were
babies
going to
into
say,
space, not so much.
45 or something.
Yeah, I mean,
I know we all want to shoot babies into space, but
if we assume that humanity doesn't ever end, we don't ever go extinct,
Yes.
okay, then it is possible in millions of years that we could get to other stars in this small portion of the galaxy.
So even the closest. Do we know anything? We haven't found anything closer that is more habitable.
We have found some, I think.
I mean, closer that is more habitable, that might be correct. We've probably found closer things, but not more habitable.
Yeah.
I mean, 40 light years is really close galactically. I mean,
Right.
this is really
But
very
they're not the closest exoplanets in the habitable zone, are they?
That I actually don't know.
And I mean, I know that there's always talk of like, colonizing Mars and things like that. Is that something you think that might be feasible in our lifetime?
By colonizing, do you mean have a man on Mars, or do you mean like set up a self-sufficient like colony that people
A
live in?
self-sufficient colony.
I think that if humanity tried, it would. I don't know that it will because
The cost.
I mean, I don't think that the Earth is just going to decide to. I think if they did decide to, it would be possible. But man on Mars in our lifetime, I'm hopeful for.
Okay. Have to scale down.
but we
my-
put Matt Damon on Mars already.
I read that book. Did not see that.
I want to read it.
Did I see that movie? No, I saw Interstellar. Were they the same?
No,
Wait, wasn't Matt Damon in it on a planet?
The Martian.
So confusing.
Matt Damon just goes everywhere.
We just keep shooting him into space, and yet he comes back.
Yeah, it's just you have to realize how far away Interstellar distances
Yeah.
are. Okay.
So what happened to that weird drive thing that seemed to defy the laws of physics in that experiment that may or may not have been a measurement error?
It was. I actually have had that conversation with someone else. Yeah, it's unclear, right? So this is the vacuum thruster microwave box drive.
Yeah, I'd forgotten about that from a long time ago. Yeah. We've been shooting things into space to like propel themselves on like modules and stuff. Or, I don't remember. There was some weird drive that was sent out.
No, we have not. We do not
No,
send
we've
out.
not done this. Okay.
This new drive is a drive that they're trying to show is even possible. Try to make one.
Okay.
We don't put that shit on our satellites. We do have a couple ion drive satellites out there, but that's normal. You're literally is just a regular ion drive.
Okay.
You just have, I think they're potassium ions. Just potassium ions, and then you have an electromagnet, and you just charge them and shoot them at the back. It's like a near limitless source of fuel, and you are getting 1 ion's worth of propellant at a time, so you do not accelerate very quickly, but you accelerate forever, because you're basically never going to run out of fuel. So, if you want to get somewhere very far away, it's better than like rocketing for a year and then coasting, because you're just going to get the smallest acceleration, but over time, right, it's exponential.
What's the distance threshold where it starts to make sense?
I don't know. I don't know that. I mean, I know that we have some ion. I think the one that we sent to Pluto is an ion drive, for instance.
That's what it was. That's where it came from.
But the weird drive that Jesse was asking about was this vacuum thruster box. So it's termed a reactionless drive, because if the measurements are correct, then they are experiencing thrust within the cavity at the expense of no reaction mass.
Okay.
Okay. So I think what the resonant cavity thruster, that's what it's called. I think the what they claim is that you basically you have a bunch of microwave. You have like a microwave emitter, like a microwave, right? A microwave oven.
I'm now picturing a microwave,
right.
a real microwave.
But you just have a device that shoots microwaves into a box. That's what ours does.
Okay.
And we put food in it and it cooks.
Yeah.
Instead of putting food in it cooks.
We take our microwave, put it in a cardboard box.
No, we're not putting microwave in a box. We are shooting microwaves into a box. The microwaves are in the box. Microwaves are the light, not the microwave creating device.
Okay.
So we shoot these microwaves in a box, and we are shaping the box somehow such that we are vectoring the microwave so that they hit the sides unevenly. Right, in a microwave oven, they're all bouncing around, so 1/6 at this side, 1/6 at this side, 1/6 at that, like that. This one, it is shaped such that, and it's called a resonant cavity because I think you have to shape it such that the resonance of the cavity is the frequency of the microwave, so that it bounces around like a trillion times. However, somehow you do it. You create it so that the microwaves end up always hitting only one side of the box.
Because he's a very important guy.
Who is it?
John Wilkes Booth, because he...
Oh boy, just more
So
reassuring.
we're pro-Washington, anti-Lincoln, is that it?
Yeah. Okay, do your thing. Have fun.
Can that guy be killed by the enemies?
Yeah.
He's just a guy in a green suit?
Yep. Thank you.
The enemy just coldly kills.
Did I kill the other guy? Nope, he's still there. I think he's dead. Yep. And this is the Order of the Raven, the Black Raven.
Also not on your side?
There's really nobody on my side in this, well, there will be eventually. Oh shit, I'm drunk. I drank too much wine!
So it was health what makes you drunk?
Yeah, if you drink too much alcohol in a row, you start getting...
But what's the advantage of drinking the alcohol in a row?
Plus health minus salt. So if you really need health, you just drink a bunch of the wine and it refills things, but then you also get drunk.
So we have a weird shaped box.
It's a weird shaped box.
Weird shaped box.
So you direct the microwave somehow, resonance or shapes or whatever, to only bounce off one side of the box. They don't bounce off all the sides, just one. So you have this box, and microwaves keep hitting only one side. That's going to generate thrust and impart directional force on the box. Okay, but all that's happening is microwaves are bouncing around in a box. You're not using it once you've created the microwaves. That's it. The microwaves just continue to bounce around, but they only bounce and hit one side. So basically, you set up this thing, put the microwaves in it, and then it just keeps getting thrust.
And you take that box and you attach it to the outside of a device to the ship.
That doesn't matter. Because the point is, can we create a drive that generates thrust with absolutely no reaction mass?
And we want to do that basically because we would have infinite, thrust.
You have exactly what that says, right? You need no energy to have thruster. And so, as Jesse alluded to, it pretty much breaks all the laws of physics. So people are very skeptical. The Chinese may want to claim that it worked, One American made one, claimed that it worked. His data, well, of course, Chinese don't release any data, so you can't replicate it. Or maybe it wasn't American. So Chinese made one, said it worked. They don't give any data. Or
They don't share.
information that you can, that will make it replicable. Someone else made one, said, hey, I have a tiny bit of frost, which is almost close enough to be like measurement error. And then like when you replicate his data, I think it does turn into within the realm of measurement error. Like it does indicate, yes, you get 0.00001% frost, plus or minus 0.001%, something like that.
Yeah.
And given that it would break the laws of physics so much, you pretty much, it's not going to be accepted or anything until there's real definite proof. So it seems like that is not something that would ban.
Can't see anything.
But it was interesting to learn about. Like when I was learning about it, I was like, this is black, because there's a lot of weird physics stuff that I'm not super up on.
And then I have some silly questions that you may be able to answer for me.
Okay.
Are you a Star Trek guy or Star Wars fan?
Star Wars.
Star Wars. Okay.
I mean, I've watched my fair share of Star Trek. I'm familiar-ish with
Are
it.
you familiar, like, to the level of details of, like, their ships? Like, the engines and stuff? So, like,
Like
they
warp
have
nacelles?
warp drives.
Yes, they do.
What is a warp drive?
In the Star Trek universe?
Yeah.
So in the Star Trek universe, warp drive is just going faster than the speed of light.
So they could, in their universe, go faster than the speed of light.
Yes. It's extremely common in a very high number of science fiction
So that's what I was
universes
going to ask,
go.
is to put these 7 planets that we have into, like, the Star Trek or the Star Wars universe. Could those guys visit it in a quick amount of time?
Instantaneous.
Okay.
Really.
I mean, they can go pretty much as fast as they want to, right?
They have warp drive.
Right. And Star Wars is hyperspace, and Larry Niven's known space has faster than light, and the Code Dominion universe has faster than light. I mean, everybody does, because otherwise you can never get to any other planet ever.
Yeah.
It's like it would make a very boring, not boring. It would make for a terrestrial-seeming science fiction universe. So if you ever want to solve the problem of staying within your solar system, you need faster than light travel, because otherwise it's just completely unfeasible.
Fair.
In Larry Niven's known space universe, the faster than light drive came very
Sorry, folks, we're just doing a little bit
late,
of
quote
backtracking.
unquote, in the universe's development. So actually, they ended up using what I termed slow boats earlier. What they invented, which might be theoretically physically possible, they're not actually physically possible, is they used for their propulsion giant fusion-powered ram scoops. So they would basically launch into space on a regular rocket this engine.
Yeah.
This engine would have huge magnetic field generators. Okay, so that would generate magnetic field, like thousands of miles across. I mean, humongous.
Yeah.
Right. Okay, and because these magnetic fields would interact with the interstellar ions, like just hydrogen ions, protons, right? Hydrogen nuclei hanging around, which are charged, and would get interact with these magnetic fields and guided around magnetic fields into the fusion center of this drive, and then you'd have all of this hydrogen. You'd compress it and create fusion, and then shoot all this hot fusion exhaust out the back to make a rocket, a fusion rocket. Okay, and the thing is that as the faster this thing goes, the more interstellar hydrogen and ions that it runs into, and the more fuel gets sent into the fusion, the more fusion you get, and the more thrust you get, so it ramps up just like an ion drive does. It ramps up. It's consistent acceleration, except in this case, actually, it gets more efficient the faster you go. So it's even better than regular exponential acceleration.
Sadly, still science fiction.
Well, I mean, we don't have A, fusion.
Okay.
Okay, controllable fusion, I should say. We don't have controllable fusion. B, humongous powered magnetic field generators that can generate these huge RAM scoops. Okay, I mean that it probably would take more energy to do that than like powers the city. I don't know. 3, like if any, I mean you can't put that near anything. Those magnetic fields like would kill a human instantly. I mean these things have to be so powerful. It is science fiction, but it doesn't break the laws of physics. Science fiction. Okay, whereas all-fashioned light travel breaks the laws of physics. Science fiction, not even possible. These things are theoretically possible, just perhaps not ever practically possible. I'm sorry, bud. Like,
I know,
space is big.
You crushed me. You crushed my dreams and my hopes. So then you said, like, possibility of Mars in your lifetime.
Yeah, absolutely. We can get there.
Should we be worried about extraterrestrial life coming to visit us? If this is so hard and difficult to do.
I mean, no, I don't think it's a reasonable worry. I think there is I think
What is this?
that is not beyond
our Father?